Hello dear students, today I will discuss about Newton's forward interpolation formula and backward interpolation formula. Okay, interpolation, just in the previous class I have already discussed about interpolation means whenever we give a table with data, the values of x corresponding values of y's, if we want to find the value of dependent quantity y for a particular value of x within the range of the values of x, then that process will be called interpolation. So by using forward and backward difference, just I have discussed in the previous class, forward operator, backward operator, center difference also. So by forward differences, backward differences, we can find two formulas, interpolation formula, Newton's forward interpolation formula, Newton's backward interpolation formula. Forward difference are the values of a table. Whenever we prepare a table for differences, so forward differences are beginning of the table and backward differences are from end side of the table. Just we have already seen in the previous class. So here Newton's forward interpolation formula. Interpolation means just the values of x, values of y, this is values of x, this is values of y, and if within this range for a particular value, in between for a particular value, we want to find the value of y, that is yx, then that process is called interpolation. Okay, so this value may be from in the beginning of the values of x or in the end of the values of x, this targeted value. If this value lies in beginning, then generally we use forward interpolation formula. If lies in the end of the table, then just we use backward interpolation formula. Depend on backward differences, because backward differences are leading differences like this and forward differences are like this. So whenever the values are likely to lie in beginning of the table, then we use forward interpolation formula, and when the targeted value lies in the end of the table, end of the value range of the values of x, just we use backward interpolation formula, here forward interpolation formula. Clear? So here suppose for Newton's forward interpolation formula, what is the formula? Just we use binomial expansion and relation between operators used. Okay, so suppose we are given here Newton's forward interpolation formula, just we are given the values of x and y, this given table. So this value of x is x0 equal interval x0 plus h, x0 plus 2h, x0 plus 3h, up to like this. Suppose here x0 plus n. up to this. These are the values of x. At equal interval of differencing is h. Clear? Corresponding value, just we note down how 0 times of h, so 0. Y 1h, y1. Corresponding value y2. Corresponding value y3. Corresponding value yn. Also we can write y3 means what? Y x0 plus 3h. This and y3 both are same. Clear? Both are same. So this is the notation. Just we write only this 1, 2, 3 and n here. These are the values of entries. Okay. Now suppose we are having this table with equal intervals and we have to find for this value given value of y is this, this value given value of y is this. Now we have to find the value of the function y, value of the function of x, yx, value of the function y for, just we know y what? Fx. We want to find the value of fx, that is y, for a particular value of x, for a particular value of x which lies in this interval or outside, maybe. That is here. Suppose x is here. Suppose x is here. Suppose x is here. Then we have to find the value of what? Yx. Clear? Yx, that is what? Fx. We have to find this value. If x lies here, then we can take origin as this value, just near. We know after making difference table, the leading, if we take origin this, then this will be y0 and this differences, leading differences will be like this. If we take origin this, then this is leading term and difference will be here. This difference will be used. If we take origin this, then these differences will be leading differences. If we take origin this, then difference will be, this difference will be used. After making the table. Table making is simple. This minus this, this minus this, this minus this, and perform the table. Okay? So here, this. So which value of x will be origin value? That is, just we will put x0 equals to that. Okay, suppose we are given 2, 3, 4, 5, 6, 7, 8 and we have to find the value of function for y 4.5, that is here. Value is lying here, x equals to 4.5, x equals to 4.5. Clear? Then origin will be 4 and this value is y and this difference will be used. Clear? So, this is the method for taking origin value. Okay? Now, formula. What will be the formula? We know the shifting operator. Suppose or P y equals to what? X plus ph, interval of difference. This is our shifting operator, we know. Shifting operator means en fx is what? Fx plus nh. This is our shifting operator. So by using this shifting operator and its relation and binomial theorem, we can get a formula for interpolation. Okay, so here suppose interval of difference in here this type of values are taken x0, x0 plus h, x0 and so on, and values of function are entries y0, y1, y2 and y3 and so on. So here for finding the value of fx for a particular value of x, take x equals to x0 plus ph, where p is any real number. Just like suppose here x value x0, x0 plus h, x0 plus 2h, x0 plus 3h and so on. If value is here x, then what will be the format of this? X is equals to x0 plus 2 and any real number we can take between 2 and 3. That's suppose that is p. Then value into what? x0 plus p into h. So we can write like this. Okay. So our targeted value is what? Yx. That is fx. That is, we can also write p because we write x0 plus nh for y value n symbol. So in place of this we write n. So x0 plus ph, in place of this we want this value. This means what? This is x. So yx means what? Yx means yx0 plus ph. It can be also written as yp. P is any real number. So we can write this or this or this. Anyway. Clear? So now we have to derive formula for forward interpolation formula here. We have E power P fx is equals to what? Fx plus ph. E is shifting operator. E is shifting operator. There we want what? Y x. What? Y x0 plus ph. What? Y p. You can write any of these three. This. Clear? So this is equals to y means what? Y equal to fx. Here y means this is yx fx. Same thing. Clear? So yp is equals to yx0 plus ph equals to what? F x0 plus ph. Same thing. All are same. Because yx, x means what? x0 plus ph. x0 plus ph is denoted by also yp. That is what? Yx equals to fx. That is fx0 plus ph. It can be written as by using shifting property e power p, any real number, f x0, x0. Clear? Now, e is what? E is 1 plus forward tail in terms of forward tail, or p fx 0. Also we can write fx0 in place of fx0. What we can write? 1 plus y0. You can also write, we got that for x, values of y0 is corresponding to x0, fx0. So y0 we can also write fx0 or y0. And this is can be expanded by binomial theorem, 1 plus x power n. So what will we give this formula? 1 plus p forward tail plus p minus 1 upon 2 factorial del square, and p minus 1, p minus 2, 3 factorial, third difference, and so on. Here y0, you can also write fx0. So this is equals to, on applying this is operator, this is the operator relation. Okay, this on applying y0, so here y0 plus p is real number and del is operator, so y0, first difference, plus here p minus 1 upon 2 factorial, second difference of at y0. So also you can write p minus 1, p minus 2 upon 3 factorial y0. This y is equals to this. Clear? But this is the main notation. We can be find from here. P equals to what? X minus x0 by h. Okay? So which is known as Newton's forward interpolation formula. Newton's forward interpolation formula, or it contains y0 and differences of y0, first order, second order, third order, fourth order, and so on. Based how many differences will take? Based on the table. This is Newton's forward interpolation formula. This formula is used whenever the values of targeted values of x lies in the beginning of the table. Clear? The first line use. In a similar fashion, we can find Newton's backward interpolation formula. Okay, Newton's backward interpolation formula is based on backward differences, forward tail, and backward interpolation formula contains backward tail operator. Okay. So this formula is important, so note down it. And for finding Newton's backward interpolation formula, just we know the whenever we prepare the table here, the main thing is what x0, what will be the value of x0, and in case of backward differences, we know in case of backward differences, so we see that but the value of x0, x0 plus h, x0 plus 2h and up to x0 plus nh, suppose n values are there. Okay, corresponding value, this is value of x, values of y, what? y0, y1, y2 up to yn. Now, whenever the value of x, targeted value of x lies beginning, then forward difference table use. And here, when the targeted value lies in the end of the table, end of the range of the values of x, when here, then we see that when we prepare the table, y1 minus y0 here, value here, and then these, and then these, and then these, and then this. This is the technique of finding table. So, this value, this, and these are the differences. Okay? Forward differences. If it is origin, then these value are used. But backward differences shows if this is origin, this, then you can use these differences, because these differences are at n, because this is backward difference yn, backward difference square yn, backward difference cube yn, backward difference 4 yn on this value. Okay, so if it is xn, suppose this is xn and xn, so origin will be this point for backward difference table, and backward difference table and backward difference formula we use origin value this. If our targeted value lies nearer to this, generally our origin value just follow this origin value. Targeted value follow the origin value. If this is origin value, then targeted value will be here. If targeted value is here, then here x0 plus n minus 1h, this will be the xn minus 1, this will be the origin value, because targeted value is here. Targeted value is here. Just follow value here. Now this will be the origin value, and difference will be used this. This difference will be used. This will be the origin. So this value will be used for backward difference table. A backward difference is used when the target value lies in end of the table or outside, little ahead to this value. Here target value, then will extrapolation, because out of range, before the range or after the range, then extrapolation. Before the range, then forward formula is used. After the range, then also backward formula is used. Clear? So for backward interpolation formula, we use here y xn plus ph. This is the n. Here targeted value is here xn, and these differences will be used. Clear? Simple this. And formula is likely to be same, but there are sign changes and differences are changes. Okay, so forward interpolation and backward interpolation formula. So for finding backward interpolation formula, we use here xn, here xn, here xn, here xn. Also you can write. And backward difference formula. For backward difference formula, here the relation E equals to 1 plus forward del, that is the relational operator. Okay, now here we know also that like E equals to 1 minus backward del inverse. This we know. E equals to 1 minus backward del inverse. So we can use this relation in place of this for converting in backward differences. So here in place of E, just we have to write 1 minus backward del inverse or P F X. This. So this can be written 1 minus backward del or minus P minus 1 into P minus P fxn we can write also xn fxn xn. Now by using binomial theorem we can expand it. By binomial theorem we can expand it. Here minus, so both all are will be pluses sign. So what will be the expansion? 1 plus P backward del P plus 1 upon 2 factorial backward del square P plus 1 P plus 2 upon 3 factorial backward del square. Y xn. Okay, xn not yn. Yn. Clear? Here. Yes. Now apply it. Yn plus P backward del of yn. First backward difference of yn at yn. Okay, and this P plus 1. So here sign is maintained, plus sign, and in forward formula minus sign. Okay, here del square yn plus P plus sign is here. Okay, P plus 2 by 3 factorial backward del q is q y n. So this is the formula for targeted value. You can write also yp. Okay, so which is known as Newton's backward interpolation formula. Newton's backward interpolation formula. It contains yn and its differences. Backward difference, that is from back side of the table. So this two formula, Newton forward formula, Newton backward formula, are used for interpolating the value of the function forward for finding the value of the function when targeted value of x lies beginning of the table, and when lies end of the table, then backward formula is used. So Newton's forward formula and Newton backward formula are very useful for interpolating. Okay, these are two formula for Newton forward and backward. Now take some questions for solving. Okay, so here we use this formula and especially note down what will be the value of x0 origin. Our origin value is what, and also what in case of backward differences table, then what will be the origin value and targeted value. How can we write the value of p? Just because in formula there is the value of use of the value of p. Okay, so here we use formula take the questions given. From the following table, estimate the number of students who obtain marks between 40 and 45. So here table just give in grouped as a grouped data format. So here marks are given interval 30, 40, 40, 45, 50, 60, 60, 70 and 70, 80, and a number of students are given for this interval. So marks between 40 and 45. So how can we find the marks between 40 and 45? Because they are the group data. So here we see that 30 to 40, 40 to 40, 50 and so on. Number are given. Now in this table, this group data, there marks, 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 marks. So here we can prepare the table because marks between 40 and 45 means what? Marks less than 45 and marks less than 40 between marks. Number of students obtaining marks less than 45, that is why 45. So we can write marks less than 40 is this, marks less than 50 will be sum of this, marks less than 60 will be sum of this. That is cumulative frequency we require. So marks less than 40, 50, 60, 70, 80 and marks less than 40 we have this, and marks less than 45 just we have to find 40, 40, 50, 60 and so on. So here 45 is here lie. So beginning of the table we can use forward difference table. So from here just we have to find first y45, that is marks less than 45. Then we can find the marks between 40 and 45. How? Y45 minus Y40. Y40 is this. Marks less than 40. And marks less than 45. Less than 45. Less than 40. So between 40 and 45 you can get. So we have to find the value Y45 after making cumulative frequency table. Less than 40, less than 50, less than 60, less than 70. Just we can make it the table. So here for finding marks between 40 and 45 we have to prepare the table just like solution. First of all we have to prepare the table. We have to prepare the cumulative frequency table. We have to prepare the cumulative data, cumulative frequencies, cumulative frequency table. As for this question's frequency Table marks less than and number of students. We can prepare table like this. So data is what? Thirty to 40 means 40, 50, 60, 70, 80. Means less than 40. The marks is given what? 31, 42, 31. 31. Marks less than 40 means 30 to 40, less than 40, 31. And then for 40 to 50 is given what? 42. So, what will be the value? 42 plus 31. 3, 73. 73. This is the cumulative frequency. Similarly, 51 for 124. 124. And then 159, 190. 159, 190. How can you make it? Just add. First value, second value, first value, then first and second add, then first, second, third add, then first, second, third, fourth add, and then first, second, third, fourth, and fifth. 190 up to 159, 90, 31, 35. Okay. So this is cumulative frequency table. This table can be used for getting marks less than 45. Marks less than 40 is 31. So marks less than 40. So we have to prepare table. Now, the forward, not only forward, because for forward, backward and central difference. Table preparation is same. So we can, because here we require only 45 is here. So forward difference table we can write, or we can also write simple. The difference table is given as follows. The forward, backward, central are same. The forward difference table is as follows. For three differences, forward, backward, central, table preparation method is same. So here, value of x and value of y. Clear? Value of x is 40, 50, 60, 70, 80. Clear? So this, you have to prepare table very clearly. Okay. So first difference. Second difference. We require forward difference, so just write forward operator. Y and up to fourth difference. Just write. Okay. Clear? We have to prepare the table first. This is table. Table preparation is very simple. So just write the value first. 31, 73, 124, 159, 19. The 73 minus 31. This minus this is will be written here. So 2, 43, 42, 1, 51. Just this minus this. 1 and 5. And this minus this. So 5. Just write in between here. Between 5, 3, 35. Here 9. 1, 31. 31, 35, 51. 31, 35, 51, 42. 42. Yes. Just difference. Only difference. This minus this minus this minus this minus this. Now, this minus this means 51 minus 42. 9. Okay? 9 in between this. This minus this. 4. 6, 16. 35 minus 51. 35 minus 51 minus 16. This minus this 9. And this minus this 35 minus 4. Minus 4. Just write in between. Okay? Minus 4 minus 16 9. Now minus 16 minus 9 minus 25. And minus 4 minus plus 16 minus 12. I think 12 here. Okay? 12. Minus 25, 12. Now 37. 12 minus this. 37. So this is the table. Just like triangular form. So backward difference is there and forward difference are there and central difference in between. So here table preparation is main thing. So you have to create and prepare the table very sincerely. Okay. Now we have to find y45. Marks less than 45. So marks less than 45. Just we have to find marks less than 45. So here we have to take origin value what? 45 is here. So x is here. So this will be x. We have to find y45. Okay. So let x0 equals to 40. Let x0 equals to 40. So if this is 40, then this is y0. And x equals to 45. Then x equals to x0 plus ph implies 45 equals to 40 plus p into h. H means interval of differencing. 40, 50, 60, 70, 80. They are equal interval. So 10. Difference is 10. So h equals to 10. 10. So from here we can find p equals to 45 minus 40 upon 10. That is 5 by 10 equals to 0.5. Sorry, 0.5. 1 by 2. 0.5. Clear? 0.5. So actually find p is can be found by x minus x0 by h. This is our formula. No? So p is equals to point. First of all, you have to find p. This is required. Clear? Now for finding y45, formula will contains p and y0 and all the differences of y0. So here this is x0. So this is y0. This is y0. Clear? So we can write it y0 and all the differences. These differences are used. This is what? Forward del y0. This is what? Forward del square y0. This is forward del q y0. This is for 4 y0. These are the differences. This is origin, so these differences will be used in the formula. Clear? So from table we have y0 equals to 31, del y0 equals to del square y0 equals to del cube y0 equals to and del 4 y0 equals to. All values are this 42, 9 minus 25. 42, 9 minus 25 and this is equals to 37. These are the differences. These differences will be used. Only 45. So now we just delete it and use formula. Okay. Our target is what? Y45. We can write y45, y.5, etc. Now, using Newton's forward interpolation formula, we know interpolation formula yx equals to targeted value yx 45. So y x equals to, what is the formula? Yx equals to or yp equals to y0 plus p first difference plus p minus 1 upon 2 factorial second difference of y0. y0 and so on like this. Now implies y x means 45, y 45, we require this value, and y0 31 plus p 0.5 first difference 42 plus p minus 1 0.5 minus 1 upon 2 factorial 2 into 1 second difference 9. Okay, so just write total formula here. Formula p minus 1 p minus 2 upon 3 factorial del q y0 and other portion is also p minus 1 p minus 2 p minus 3 upon 4 factorial del for 4 y0 with 4 differences Up to 4 difference we have to take. So this is second difference. Have to take second difference 9 and then plus p minus 1 p minus 2 upon 3 factorial is 3 into 2 into 1 into third difference minus 25 and also 0.5 minus 1 0.5 minus 2 0.5 minus 3 p minus 1 p minus 2 p minus 3 upon 4 factorial. So 4 into 3 into 2 into 1 into fourth difference 37. Okay, just up to this we have 4 difference, another difference will be 0. So this just you have to calculate it. Okay, after calculating you can get the value. Clear? Minus just use the formula and in place of p just use this value 0.5 and differences from table, these are the differences, use these differences and just calculate. By using calculator you can do it 47.85 47.87 after simplification. Just write it. Calculate by using calculator. You can write like this. Okay, round off 47.87. That is, we get y 45. The use of formula. How can we use formula? What will be the value of y0, x0? That is main thing. Okay, so we get y45 equals to this. So we can write here now. We have to find the number of students getting marks between 40 and 45. Okay, so from table y45 equals to this. Here this can be written 48 approximate 48. So we get number of student getting marks less than 45 is what? Student number of obtaining or getting, number of students getting marks less than 45 is 48. Okay. And also number of student getting marks less than 40 is 31 from table. 31 from table. Just cumulative frequency table. First marks less than 40, 31. Therefore, number of students obtained marks between 40 and 45 is given by what? 48 minus 31 equals to 70. Clear? 48 minus 31 is 70. This is the answer. So here main thing is what? The using forward interpolation formula. Newton's forward interpolation formula for interpolating the values y45. For that we make table. From table just note down the y0 and its differences. Okay. So also we can use backward difference table for getting values. So for that, take another question here. Just see one thing, that we can also find polynomial from our previous discussion. We know that if we are given 3 entries, then second degree polynomial can be approximated for the function. Function can be approximated for the as a polynomial of second degree. If 4 entries are given, then third degree polynomial can be approximated. So here, if for by using yx equals to formula, here suppose just targeted value is our value is x. That means x minus x0 upon h. This is p equals to. If we take from a table, this is particular value, this is particular value of, and this x is x. For example, x0 equals to 40 and h equals to 10. Then we can find this value equals to x minus 40 by 10. Here x, p is in terms of x. Now this p is used in this formula, then and differences also we can find from the table, and we will see that this will contain x, function of x. So we can find yx as a polynomial, okay, by using given data. If 3 entries are given, then we can find as a second degree polynomial. If 4 entries are given, we can find cubic polynomial. Okay. After finding polynomial, we can interpolate, extrapolate for any particular value of x in between the range of values of x. Clear? So here, take the questions for this. Okay. So question is, find the cubic polynomial which takes the following values. Cubic polynomial which takes the following values. Here cubic polynomial. So here given values of x are 0, 1, 2, 3 and fx corresponding values are given. Hence and otherwise evaluate f4 is also hence or otherwise. Hence or otherwise means you can use backward interpolation formula also, interpolation formula, or by using that polynomial you can get. Just I have told now. Okay. So here for this questions we have to find what? Cubic polynomial means third degree polynomial. So just we see that the given table is what? We are given x value 0, 1, 2, 3, and fx, you can say y as what? Values 0, 1, 2, 3, 1 to 1, 10. 1 to 1, 10. Simple data. Maybe the data are large value, but here simple data. The main thing is technique. How can we find it? Okay. So here just we have to find cubic polynomial. Here we see that values of y are given, 4 values are given. So we can approximate this function as a third degree polynomial. For that, we have to use difference table. So make difference table first. Okay. We prepare the difference table for this data. For this data as difference table, because from same table we can find forward, backward, center. So the value of x y, first difference, second difference, third difference. Here we write forward difference, backward difference. So just write first difference, because we will use also backward difference here. So first difference, second difference, third difference, first, second, third. Okay. Fourth difference is also third difference, because fourth difference will be 0. Third degree polynomial, fourth difference. Here just prepare the table. Zero, 1, 2, 3. Okay. So take appropriate dimension of the table. Clear? So table preparation is very simple. How? 1 to 1, 1, 2, 1, 10. Now 2 minus 1, 1. 1 minus 2, minus 1. 10 minus 1, 9. Minus 1, minus 2. 10. 10 minus 2, 12. Okay. 12, 10 minus 2, and 9 minus 1, 1, and 10, 1, 2, 1. 10, 1, 2, 1. This is the table. Very simple. As a simple process, just you have to prepare the difference table. Now, for finding polynomial, just we have to take what? Here x0 origin value is made. So you can use forward difference formula or backward difference formula. Okay, interpolation formula or interpolation formula forward or backwards. Just we have to use here forward interpolation formula. For that, take here we take x0, origin value is 0. Suppose this is x0, this is x0. Okay, x0. Then this is y0, this is, if we denote like this, this is del square y0, this is del cube y0 for using forward difference table. If we suppose this difference are forward difference, if this is origin, then first leading entry is y0 and this values will be used. Okay, and we also require the value of p. So here we take x0 equals to x0, 0, and x equals to x. Then p equals to what? X minus x0 upon h. H equals to 0, 1, 2, 3. 0, 1, 2, 3 means what? 1 difference. Difference is 1. So here h equals to also 1. Okay, h equals to what? 1. So we get x minus x0, x, just x. x0 equals to 0 and h equals to 1. So x minus 0 by 1, x, p equals to x. And differences, y0 equals to 1, and from table forward y0. y0 equals to what? 1. First difference of at y0, 1. And second difference, y0 minus 2. And third difference, y0, 12. This. And these are used in forward interpolation. So using Newton's forward interpolation formula, we get what? X equals to y0 plus p del y0 plus p minus 1 upon 2 factorial del square y0 and p minus 1 p minus 2 upon 3 factorial del q y0 and so on. This is forward interpolation formula. Clear? Here just put the value y01 plus p equals to x, and difference is, first difference 1 plus p means x minus 1 upon 2 factorial means 2 factorial means 2. Second difference is minus 2 plus p means x, so x minus 1, x minus 2 upon 3 factorial. 3 factorial means 6. 3 factorial means 6 into third difference 12. And further are not there. Now just solve it. 1 plus x plus 2 cancel minus x square minus x. 6. 2 times of plus 2 times of x square minus x into x minus 2. just calculate it. After calculating, we can get polynomial as after calculating you can get the 2x cube minus 7x square, 2x cube minus 7x square, 2x cube minus 7x square plus 6x plus 1 plus 6x plus 1. 2x cube minus 7x square plus 6x. 2x cube minus 7x square plus 6x plus 1. Okay, yx equal to this. Just multiply it and simplify it, you can get this. So this is the required cubic polynomial. Yx equals to fx equals to. This is the cubic polynomial. Okay, first answer is this. And secondly, here say hence and otherwise find the value of f4. Okay, f4. Yx means what? Fx is this. So here we see get fx equals to 2x cube minus 7x square plus 6x plus 1. Just we get this polynomial right here. Okay. Now hence or otherwise find f4. Fx means yx. Same thing. Okay. Yx or this. So f4 can be found by putting x equals to 4 here also. And also f4 can be found by using backward interpolation. For backward interpolation formula, Newton's backward interpolation formula, here backward interpolation formula is used for finding f4. f4 we can also find the value of this hence and otherwise. If we use backward interpolation formula for finding f4, f4 means what? f4 means y4, y4, f4, f4. That means what? Here x 0, 1, 2, 3 and x equals to 4 is here, extrapolated, is outside of the range. But x equals to 4 lies here, end of the table. So we can use backward interpolation formula also for finding f4. For that, because x is lying here, then x0 will be 3. X not x0, we say y xn, xn. Okay? So, for that, for, we can write like this. For finding f4, that is y4, we take x0 not xn is equals to 3, here 3, this is, and x is here. Okay, and x equals to 4, here 4, happy. Then p equals to x minus xn means like this. X means 4 minus 3 upon 1. 1. P equals to 1. Here P equals to what? 1. Clear? And if this is origin, then this is yn, and in backward notation, this is backward yn first order, this is backward, and this is backward y, and n means here at 3, n here, so at 3. Okay, this is the value. Okay, we can write like this. Also 0, 1, 2, 3, we can write here x3. Here we can write x3, here 3, here 3, here 3. This is backward del. So this differences are used for backward formula because 4 lies here. So from table here, y3 equals to 10, and backward formula first order equals to 9, and second order y3 equals to 10, and this backward 3 equals to 12. Using these values, using Newton's backward formula, we get what? Y4, x equal to 4, yx, y4 equals to y3 plus p backward del y3 plus p plus 1 upon 2 factorial. Here plus sign is there. Backward del of square y3 plus p plus 1 p plus 2 upon 3 factorial. Backward del y3. This is the formula. So just put value here. Y3 10 plus p1, p is 1, first backward difference 9 plus p1, so 1 into 2, 1 into 2 upon 2 factorial 2, del backward del square 10 plus 1, 1 into 2 into 3, 1 into 2 into 3 upon 3 factorial 6, third derivative 12, sorry difference, just like this. Now you can calculate it. Okay, so 10, 9, 10, 12, 10, 9, 10, 12 like this. 10, 9, 10, 12 equals to, we can see the value 41. So this is the value of y4. Use backward interpolation formula because x lies here. X lies here. End of the table. Clear? So y4 equals to 41. That is f4. We can check it by using this polynomial also. X equals to 4, then 2 into 4 cube minus 7 into 4 square plus 6 into 4 plus 1. Just you can calculate it. 41. Okay. So this is the solution of these questions. Okay. So just use forward and backward formula, interpolation formula, Newton's interpolation formula for solving these questions. These are the questions for your attendance. Okay. 2 questions are for your attendance. Just do it and send me for your attendance. Okay. So remember that the formula, how can use the formula? Just backward interpolation formula, forward interpolation formula. Forward interpolation formula is used for whenever the targeted value of x lies in the beginning of the table, okay, or in between where the targeted value lies, just previous value of that is taken as a origin, okay. And for backward, so when the value of x, targeted value of x lies to the end of the table, and just its previous value will be the origin. Origin value is required for getting value of p. Okay. So solve these 2 questions for just like this, x0 plus h and up to x0 plus nh. This is y0, y1 and up to yn. Whenever the value here, then which will be the origin? Which will be the origin? That is important. Origin value for forward, when value like here, for forward origin value x0. So p equals to what? P you have to find. P equals to means x minus x0 upon h. H is equal interval. Okay. And here x minus x0 by h. So x is lying here. So this is x and x0 is origin value. Maybe this, maybe this, maybe this. If this is origin, then these differences are used. If this is origin, then these differences are used for forward. If here targeted value is here x, then backward differences are used as the origin. Okay. So just use this concept and also idea for finding what value of p. Okay. So here just we write x equal to x0 plus ph. Okay, or x equals to xn plus ph. So corresponding value is what? Yx. We can also write yx0 plus ph. We can also write yp. Here also yx, that is what? Yxn plus ph. You can write also y p it for backward. Okay. So use the concept and also forward Newton forward interpolation formula and backward interpolation formula. Just remember formula are just like same, but in a forward interpolation formula there are used forward differences just like this. What? First value y0, then p and p minus 1 and then p minus 1, p minus 2, just by using binomial theorem. So here first y0 first difference, second difference and third difference. Writing is very same, simple. So P here this by 2 factorial, this by 3 factorial and so on. This is the forward integration formula. Backward integration formula, here also we write yn, yx equals to, here yx equals to yn in backward side. So here P also backward, also y0, but here you have to write P plus 1, just P plus 1, only plus 1. Okay. So backward formula y0, not y0 here, yn, because these differences can be taken from backward side. So also here P just plus it, okay. So 3 factorial and backward at yn. This is a backward formula. This is backward formula, okay, backward formula. And this is forward formula. Forward formula. Okay. Beginning of the table, beginning and end. For beginning, use this. For ending, use this. Newton forward, Newton backward formula. And solve these two questions and send me. Okay.